Hi, in this episode we are going to take a closer look at the MGRS or Military Grid Reference System. And if you look at this desktop wallpaper, you can actually see part of it here in the form of the UTM Grid Zone Designator squares. And we're going to take a look at how you can work with the different parts of the MGRS system. First, let's go to this plugins.qgis.org site. And here there have been some development recently. So for instance, it has always been the plugins repository for QGIS. So here you can get a lot of, or most of the plugins you are using for QGIS. Recently, it also became a style hub, where you can search and preview and download styles for your maps. And even more recently, there's also been projects hub included. Not that many projects yet, but hopefully it will grow. There's also models that you can download. For this video, I'm going to use a project I've uploaded, and right now it's still under review, but when you are looking at this video, it will hopefully be available to you. And it's called Military Grids, Tools, Example, Data and Layouts. And you get a small preview about the MGRS system, a description, and there's a link to the Military Grid Reference System posting on Wikipedia. And we'll take a look at that in just a minute. And it describes that it will include some layouts and tools and so on. So let's check this MGRS site. MGRS, that's a reference system. It's not a coordinate system or a projection. So it's not supported by PROI4 by default. So in order to work with it, you need some external libraries. And first of all, if you want to read more about the MGRS system, you can check the information on the Wikipedia. It's quite extensive. But in order to work with MGRS in QGIS, the easiest way is to download and install the lat-long tools plugin. Previously, I've used my own Python libraries to do this, but since all requirements are now included in the lat-long tools, and you will get a lot more benefits when working with the MGRS, I suggest you download and install this plugin. And for this video, it's a requirement, so you need to do it. Anyway, just click download, and that will download the small GeoPackage. And it's quite a challenge to meet the requirements for the packages that you can upload to this site, because they are not only allowed to be maximum 1 megabyte, and that is quite a challenge. Anyway, it will download a zip file, and inside that zip file is a folder with a license, and the license is essentially Creative Commons 0, so you can do whatever you want with this. Then we have the GeoPackage, and the site assigns a random name to the package, because they don't want to have duplicates. Or if you upload a GeoPackage with the same name as someone else's, there will be a problem. So this is a way for them to remove that risk. However, it will be some issues with it. So let me just extract it to a folder. And let's start QGIS. I will be using QGIS 3.16, and that is the latest release at the time of the recording. And let's go to the location. And if I expand the GeoPackage, you will see there's a few data layers and a project file named Start Here. If I add that, you will get this broken data source paths. And that is because the GeoPackage is renamed from the original. That is not an issue. You can fix that. Just keep unavailable layers. And you get these warnings for the layers that are unavailable. So just click that. And then you go to your GeoPackage and the corners. Okay. That will fix everything. So now it is fixed. And the next time you save it, the paths will be updated. However, there's another option, and that is to rename the file. So just rename and remove the extra text string. And now when you open it and add it, everything should work just fine. So there you have the example data. And it's just a really small area. Primarily so that I can include the styles that I am going to use for the example. However, working with the MGRS, you really shouldn't do that in a pseudo Mercator, which is the default for this project. But it's convenient because I don't know where in the world you want to create your grids for. So it's convenient and it works to start with. So I will leave it at pseudo Mercator for now, but then I will later I will change it to a UTM projection. You also get a reminder that it will require the lat long tools plugin and that you should read the project metadata, and that you can reach by Control-Shift-P. So Control-Shift-P and metadata. And you have more or less all the information I will go through in this video. And let's just check plugins, manage installed plugins, installed. I have lat long tools installed, so I don't need to do anything else. Apart from the necessary functions that I'm going to use in this video, the lat long tools also gives you a toolbar with a lot of coordinate tools. For instance, you get this show display coordinates. If you activate that, down here in the lower left, you will get a coordinate reference for the mouse pointer. And I have it set to MGRS, but you can change that in the lat long tools settings to any of these possible options. But I will leave it at MGRS. The default, I think, is latitude and longitude. And if you click anywhere, the coordinate will be copied to the clipboard, which is really useful. And for now, I will also remove this decoration like that. Okay, included in the project are a few models. So if you go to your processing toolbox, you will find under project models military grids. And let's see. The first one we are going to use is this MGRS grid zone designator global. And if we just open the model, It's hopefully annotated enough for you to understand it, but you actually don't need to open it. You can just run it as it is. This tool is no frills at all. You just run it. You can generate it to a database or anything you want, but I will just create a temporary layer. And what it does, it generates all these different grid zone designator areas. As we move to top, move out of group, so like that. And I'll just copy the styles from the example. So this model will generate the UTM grid zone designator areas. And if we open the table, all it has is an attribute with the GZD properties or values. And all the styling does is use that as a label. That's all. As you noticed, it takes a little bit of time to generate this, but not that long. But you can imagine how long it would take to generate all the smaller parts with a model. It's possible, but the rest of the models are based on these grid zone designators. So if I use the select tool and select the grid zone designator areas I want to generate my additional data for, I can use it to generate 100 kilometer squares for the MGRS system. All I have to do is select my grid zone designator layer, choose to only use the selected features, and I have to use the iterate function. This will create one layer for each of these 6 polygons. I haven't found a way to do it in any other way, so I can get only one vector layer. It's possible to do it, I guess, by Python, but as a model, I haven't found a way yet. So let's run it. You will get some errors, but I think you just can ignore them. And here are the 6 layers. And I suggest you merge the vector layers. So use the tool Merge Vector Layers and select all 6 except the examples and run. And I can remove the layers and let's paste. No, MGRS styles, copy, styles, paste. And this layer is also a simple table with a grid zone designator, the parent layer, so to say, and the name for the MGRS 100 kilometer square. And that MGRS letters are used as labels in this layer. The styling is quite simple. It's just a simple outline, and it's just a label with the letters. It is, however, scale dependent. So if I zoom in, they will eventually disappear. So when I am beyond 150,000 scale, they will not show up anymore. There they are. That is done because when I go to a larger scale, I usually want to have the letters in the corner of the MGRS squares. So I have a model to create those corner labels. That one only takes one input, and that's the merged MGRS layer. And you can, depending on the scale you are creating your grids for, you can decide on how far from the corners diagonally they are to be placed. In this case, 500 meters is suitable for 50K maps. So I will leave it at default. Like that. And then we can copy the corner style. Paste it. And that is also styled with what? Yeah, it's styled with scale dependent visibility. So when I go in beyond 150K, they will show up. And as you see here, they are a bit twisted, and that is because I am using the pseudo-Mercator projection. So let me just switch to a suitable UTM zone. Like that. And now they are straight. I did this because I wanted the... Oops. When I go to a different UTM zone, I want the corner labels here to be presented in line with the grid for that zone. I just thought it looked nicer. So let's generate the grids. And there's a model for that. Grid zone designator, 1 kilometer grid, and that needs to be run with iterate. So do I still have anything selected? I think I deselected that. Okay, now I have them selected. So UTM grid zone, yes. Use selected features only and iterate. Run. And this takes a bit longer than the MGRS system because there's more to generate. But it is lines in this case. Let me rename that to MGRS. And those we can merge. Grids, 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 grids. Okay. Run. Close. Grids, grids, delete. And rename that. That and copy the style. And paste it. I'll just turn the background map off for now. So, the grids. The table is similar, but there are two important attributes. One is the label for the 1 kilometer line, and that's just a kilometer number. and one is a label for the 100-kilometer value of the grid line. So I can separate those two. And I have done that because I want the 100-kilometer value to be possible to print in a smaller font size. And it's hard to see here because there's something screwed up with the masking. So if I go to this, masking is enabled, but it is turned off. And no matter what I do, how I save it, it will always be turned off. So like that. Masking enabled, yes. And turn it on like that. And I need to do that for the MGRS as well. And I need to do it for the UTM zone. And that should be it. But it's not. I don't know why. And now it disappeared again. There's something really broken with this function. Anyway, that's not why we are here. So as you see here, I have two classes in the rule-based labeling. They have a different rule. The kilometer numbers have no rule, so they are always applied. And the smaller numbers have a rule. And that rule is, I think this operation is called modulus. So I'm not sure, but if you divide or have modulus 10 of this, the label, and it is 0, that means the value is evenly dividable by 10, and then this label should be used. So for each number that is evenly divisible by 10, there should be an additional small number like this. I have also placed the labels with this label anchoring at a custom position, 2%, and I've selected strict, so it will absolutely follow this outline. I found that this is useful when I'm just viewing the maps on the screen like this. For layouts, I have chosen to do it in another way, but I'll get back to that just in a short bit. So there are some style options. Anyway, there's also a couple of themes. So there's a default theme, which turns everything off. And there's an example theme that I will be using for my example data and my example layouts. Anyway, let's see. Where are we? Zoom to layer. Let's do some layouts. So I have included 3 simple layouts, and when it comes to military styled printed maps, they are required to follow a lot of standards in order to be similar between nations and so on and so on. These examples are just examples. They do not comply with all thinkable standards. And the purpose for these examples are to exemplify how you can work with MGRS and the coordinate numbers in a map layout. So let's start with a portrait map. There are some rudimentary titles and product information, scale information. There's also some required information about the map projection, scale bars, MGRS information. And in order to get information from the map, I need to reference the map in the expressions that is used here. So let's take this in bold here, the complete MGRS position. That is this expression. Let's see, there. So let's open that expression. It is using functions that are included in the lat-long tools plugin. So you get a lot of more expressions that you can use in your maps that are useful when you are working with military coordinate systems and MGRS. So one function is MGRS, and that takes the Y and X coordinate. This is a case of confusion for a lot of applications using this plugin. It is reversed. There's an explanation for it, but it's a cause of confusion. So be aware, it's lat-long tool. So you are supposed to name the values in the lat-long order, which is YX. You can use any the values in any coordinate system, but if it is not in lat-long, you need to specify the CRS for it, the EPSG code. So here I take the item variable that is named map. I will get back to that shortly. And the value for the map extent is collected with the map get function. And the Y coordinate and the X coordinate for that, together with the map projection, is passed on to the function MGRS, and you get the complete MGRS position string in return. So this item variables with the name map, what is that? That is the map frame, or the map item has the item property, item ID, map. So if you are going to use these item variables, you need to name your items in a way that you can reference. So that is why you will see in a lot of places this item variables map that is just referencing the map frame. It's here, for instance. It's yep, it's there as well. So it's in a lot of places. So let's get back to the map. This map is as simple as it gets. It's completely within a single UTM zone. So I can use the layout functions to create the grid. So the grid, there are a lot of options here. 5 and 10 kilometer are not enabled, so they are not turned on. The 1 kilometer grid is enabled. and it uses the map projection. So it's really important that your project is projected in the correct UTM zone. It has an interval of 1000 meters. And then we come to the coordinates. Oops. Now it starts to become a bit more complicated. So the custom expression for the labels. Can I zoom in? No, let me zoom in first. Like that. And custom. First of all, we have an if statement, the first part here. That is only executed if the fourth number from the right is a 0 or 0. That means even 10 kilometers, like here and like here. So the first part here is only included if it is an even 10 kilometers. Otherwise, nothing is included. And then for all numbers, we take the 2 kilometer numbers, which is the 5th and the 4th number from the right, if you understand what I mean. So if it is an even 10 kilometer, and if it is 7 numbers in total, the 7th number from the right will be replaced with this Unicode super character representing the number. And the same for the 6th character from the right. Like this. So this is a really simple way to get nice looking coordinate labels for a kilometer grid, like this MGRS or this UTM grid. There's also included a 5-minute lat-long grid. You have the option to activate a 15-minute lat-long grid. I have 2 MGRS grids. I'll get back to those. And there's a 100 kilometer grid as well. All that does is add a bit thicker line. So if I disable it, you see here it disappears. So it's just a way to make it more obvious where the MGRS 100 kilometer zones start and end. And there's also a UTM zone warning. It's a really thick red line. So if you start a layout where there is a UTM zone and you use this layout, you will get a warning. And that means that you really need to modify the layout or select another layout. So get back to the MGRS. There's 2 of them. The upper and right part of the layout. Let's move this a bit so we see the letters. So upper right. If I disable this, you see that the upper and the right letters disappeared, but they are still here on the left and lower part. So I can enable it again, like that. I need 2 of these, upper right and lower left, because QGIS will not differentiate between the upper x-axis and the lower x-axis, or the left and right y-axis. So I need 2, and for the labels, they are disabled on the left and bottom for the upper right, and the opposite on the lower left. The grid is frame and annotation only. So if I turn solid on, you see that it's basically a 1 kilometer grid, but it is offset 500 meters, so that the labels will be placed between the kilometer labels. But I don't need the lines, so it's frame annotations only. And I don't need it to be labeled on every kilometer. So in the custom expression for the labels, there's an if statement that tests if the kilometer and 100 meter numbers are 995 or 005, which means this location or this location, or this or this. If the value is either of those, then it will be printed. Otherwise, nothing will be printed. And what it does, it checks if it is on the grid number is on the x-axis. Then it takes the MGRS 100 kilometer function, this one, and get the y value. And on the x-axis, that is the y max for the item variable map extent. And then it takes the x value, which is the grid number. And it also includes the map coordinate system, which in this case is the project coordinate system. If it is not the x-axis, it will use the grid number as y value and the x max as x value, and do the same. And this will return the MGRS letters for the 100 kilometer box. And for the lower left, it's the opposite. So here we will have, instead of x max and y max, we have x mean and y mean. Otherwise, they are identical functions. So this is the way I create this simple form of layouts with an MGRS system on it. So let's get more complicated. Here we have the UTM zone boundary, and you see that the right part of the grid is leaning towards the other, and this is sometimes called a zipper grid. This cannot be reproduced in the layout in QGIS, and that is why I created the models to generate the vector layers, because all these are vector layers. So if I turn it off, and I also remove this option to follow a specific theme and update the map, more or less all the lines in the map disappear. So let's follow the theme again. However, the numbers around here, they are part of the layout. So how did I do those? Grids. I have one label for the left part and one for the right part. So let's start with the left part. If I turn it off, see here, it will turn off. I use it's basically the same as the previous map. use the map project projection. It's a 1 kilometer grid, and the expression is a bit different. So if it is on the x-axis, and if the EPSG code for the center of the map is the same as the project coordinate system, or if it is on the y-axis, this one, then the labels should be printed. But for a number that is on the wrong side, the EPSG code for that location will not be the same as the map projection, and therefore nothing will be printed. And this works reasonably well. You see here there are missing numbers down here, but I can live with that. For the right part of the map, it's basically the same, but instead of the project projection, you need to select the projection for this UTM zone, so that in the expression labels or positions that are on this side will be equal to the project CRS system. This is a bit confusing, I think, because it's not the project CRS, it's the map frame CRS. This is maybe a bit confusing because it's named project CRS, and that is not the case in this case, because we override it by setting another CRS here. So it's not the map CRS, it's overridden at this location. But it effectively changes the project CRS for this area. Also in this layout, I have not included any MGRS letters in the outline because it was easier to just have them printed in the corners like this, and using the vector layer labels. I could have included them in the outline as well, but then I would have been forced to use 4 different grids instead of 2. So that is why I didn't do it in this layout. The last layout is just more of the same, but in a different scale. So here we have a map in 250K, and it's a larger sheet of paper, so it covers a larger area. It has an index map and a little bit different. So there's more room to place things in the layout. But it's basically the same as the previous with a zipper grid. So we have a right and a left grid, and more or less the same. I could show you the UTM zone warning here. So if I enable that, I don't think anyone will miss this warning when you are using the maps. So in case you see this in one of my layouts, that means you need to use a zipper grid that you generate in another way, and then using the built-in grid functions. Okay, I think that's all for this video. Hopefully you will find the models useful, and if you go to the plugins site, the models are also available as separate downloads, so you can get them separately with some information and links to the required plugin. And as I mentioned, hopefully my project will be approved by the time I have finished editing this video and publishing it. So, see you next time!